So for our next equation is combining the equation of 10.18 and 10.99 with the equation of 10.17, we can compute the average inventory as follows. No? So this equation 10.20. So just combine the equation 10.18 and 10.19 with the 10.17 equation. So this is our formula. The average inventory is equal to 1/2 Q to S, and Q to S over D divided by Q to D is equal to Q to S squared divided by 2Q. So thus the average inventory is expressed in terms of two inventory decisions. Now how much we will order, which is the Q, and the maximum number of back orders, which is the letter S in the formula. So the formula for the annual number of orders placed using this model is identical to that for the EOQ model. With D representing the demand, we have the annual number of orders is equal to D divided by Q for our 10.21 equation. No? So as easy as that. So the next step is to develop an expression for the average back order level, because we know that the maximum for back order is S. We can use the same logic we used to establish average inventory in finding the average number of back orders. So we have an average number of back orders during the period of 1.5 the maximum number of back orders, or 1/2 S. We do not have any back orders during the T1 days. We have inventory. So therefore, we can calculate the average back orders in a manner similar to the equation 10.17. Okay, using this approach, we have average back orders is equals to OT1 plus S over 2 times T2 divided by T is equal to S over 2 and T2 divided by T. So this is our 10.22 equation. When we let the maximum of back orders reach an amount S at a daily rate of D, the length of the back order portion of the inventory cycle is T2 is equal to SD for our 10.23 equation. So as easy as that. So next is using the equation of 10.23 and 10.19. In equation 10.22, we have the S over D times S over D divided by Q over D is equal to S squared divided by 2Q. So this is our 10.24 equation. So let CH is equal to cost to maintain 1 unit in inventory for 1 year, CO cost per order, CB is equal to cost to maintain 1 unit on back order for 1 year. Okay, the total annual cost TC for the inventory model with back order becomes TC is equal to Q to S squared divided by 2Q times CH plus D divided by QCO plus S squared divided by 2QCB. That's our 10.25 equation. Next, for our 10.26 and 10.27 equation. So given the CH and CO and CB, the annual demand D differential calculus can be used to show that the minimum cost values for the order quantity Q and the planned back order S are as follows. So Q, which is the EOQ units, 2DC divided by CH times CH plus CB divided by CB for our 10.26. Magkasama to silang dalawa, ha? And then for the letter S is equal to Q times CH divided by CH plus CB for our 10.27 equation. So suppose that the Highly Radio Components company has a product for which the assumptions of